All right, so in this assignment, we're going to be continuing our discussions with solving 3D systems, but instead of using elimination, we're going to be using the method of substitution. So let's go ahead and get started with this first example. So this is just a general example with three different variables, three equations. And again, our goal is going to be the same. We want to come up with, we're going to change something from three variables with three equations into something with two equations and two variables, into something with one equation with one variable, and then we're going to be able to work backwards to come up with what the other two variables are. And so what we want to do first is get one equation with one of the variables isolated by itself. So what I'm going to do is take this first equation and I'm going to solve it for x. So when I do that, I'm going to have, I'm going to keep the x on the left, but I'm going to add 3y. So x is going to equal 3y, but then it's going to equal minus z, because I'm going to subtract z from both sides, plus the 6, which is already there. And so that is what x is equal to. And so then I'm going to go to the second equation, and the second equation is 2x, but instead of putting x there, I'm going to put what x is equal to, which is 3y minus z plus 6. That's my 2x, but then it's minus 5y minus z equals negative 2. And I'm just going to simplify this equation. If I distribute the 2 out times all three of these terms, then I'm going to have 6y minus 2z plus 12 minus the 5y minus the z equals negative 2. And then I'm going to combine like terms. I have a 6y minus 5y, which is just y. I have a negative 2z and a negative 1z, which is a negative 3z. And if I add this 12, or if I subtract this 12 from the other side, I'll have a negative 2 minus 12, which is negative 14. And there's one equation with two variables. So I'm going to do the same thing with the third equation. I'm going to rewrite the third equation, which is negative x, but instead of putting x, I'm going to put what x is equal to, which is 3y minus z plus 6. And then plus y plus 2z, that's a z there, equals 7. And if I simplify this, I'm going to distribute my negative sign, or my negative 1, so it's going to be a negative 3y plus z minus 6 plus y plus 2z equals 7. And I'm going to combine like terms then. I have a negative 3y and a positive y, which is negative 2y. I have a positive z here and a positive 2z, which is a positive 3z. And if I add 6 to both sides, this is going to be equal to 13. And so there's my second equation with two variables. Same two variables as my other equation. And so now I'm going to take a look at these two equations, which is two equations with two variables. And I'm going to try to eliminate one of these variables. And it looks like I can do that pretty easily. If I just take this equation here and write it underneath here, I'll have a negative 2y, but instead of a minus 3z, I have a plus 3z, and this equals 13. So when I add these two equations together, I will have that negative y, the z's are gone, negative y equals negative 1, which means y is 1. And so then I'm going to use one of these two original equations, or these two equations, this one or this one, to figure out what z is. And I'm going to go ahead and use this one here. I have negative 2 times y, which is negative 2, plus 3z equals 13. And if I add 2 to both sides, then I'll have 3z equals 15. And if I divide by 3, then z will equal 5. So z is 5, y is 1, and if I go back to one of my original equations, let's go ahead and use this equation, or I can use what I wrote the x equaling to figure out what x is. I know that x is equal to 3y, which is 3 times 1, which is 3, minus z, which is minus 5, plus 6. And 3 minus 5 is negative 2, and negative 2 plus 6 is 4. And so my solution is the point where x is 4, y is 1, and z is 5. So let's take a look at one more example, and you might want to pause the video and just try to do this one on your own before we do it together and see if you can come up with what the answers are. So if you've done that, that's great. If not, let's go ahead and see if we can do this one together. The goal again here is to get a variable by itself so that we can use that equation to plug into the other two problems. And what I'm going to do is take this second equation and solve it for x. And so if I solve that for x, I will have x equals, I would add y to the other side, I would add 3z to the other side, and I already have the 1 on the other side. And so x equals y plus 3z plus 1. And so I'm going to take the first equation first here, and that's 2x. Well, 2 times x, but I'm not going to put x there. I'm going to put what x is equal to, which is y plus 3z plus 1. And then I have plus 3y plus z equals negative 4. So I'm going to simplify this equation. I'm going to start by distributing the 2. I will have 2y plus 6z plus 2 plus 3y plus z equals negative 4. Then if I combine my like terms, 2y plus 3y is 5y. 6z plus z is 7z. That's a 7z. And then if I subtract 2 from both sides, this is going to equal negative 6. And again, this is a 7 right here. So there's one equation with the y and the z. And so I'm going to do the same thing, but I'm going to use the third equation this time. The third equation is 3x. But again, I'm not going to put what x is there. I'm going to put this x here. It's 3 times y plus 3z plus 1. Then I have plus 2y and plus 2z equals 5. So when I distribute my 3 out, I will have 3y plus 9z plus 3 plus 2y plus 2z equals 5. If I combine my like terms, then I will have 5y's, because the 5y and the 2y. 9z plus 2z is plus 11z. If I subtract 3 from both sides, it's going to be equal to 2. And so now I have two equations with two variables. And so I'm going to take the first equation here and copy that down. That's 5y plus 7. That's a 7 again. I don't know why I'm doing that. 7z equals negative 6. And then I'm going to take this equation here and multiply it times negative 1. So I will have a negative 5y minus 11z equals negative 2. Now when I add these together, my y's are going to cancel. 7z minus 11z is negative 4z. And that's going to equal negative 6 plus negative 2 is negative 8. And if I divide by negative 4, z is 2. Then I can go back to one of these equations here to figure out what y is. So if I go back to this one here, I have 5 times y plus 7 times z. Well, that's going to be plus 14 because it's 7 times 2, because z is 2. That equals negative 6. And so I'm going to subtract 14 from both sides, and I'll have 5y equals negative 20. And if I divide by 5, then y is negative 4. Then I'm going to plug both of the z and the y back into one of my original equations. Let's say I use this one here. I don't know, or I could use what I solved for x to be. X is equal to, I think I'm going to do that. X is equal to y, which is negative 4. plus 3 times z, well, that's 3 times 2, which is plus 6, plus 1. Negative 4 plus 6 is 2, and 2 plus 1 is 3. And so x equals, that's an equal sign, 3. And so my solution is the point 3, negative 4, and 2. And that's my solution for this system. That's the kind of thing that we're going to be doing on our homework. Sometimes you'll have to set up two systems, or a system of 3 equations with 3 variables based on a problem, a story problem. But they're all going to be involved in solving these equations, at least starting out using the distributive property, using substitution. And then once you get your 2 original equations, you can use any method that you want there. So good luck on your homework, and we will see you tomorrow in class.